Question 1, Part C. Evaluate the integral of 1 over the square root of 4 minus x squared dx from x equals -1 to x equals 1. The integrand 1 over the square root of 4 minus x squared is an even function. Hence, rather than integrating from x equals -1 to x equals 1, we get the same value if we integrate from x equals 0 to x equals 1 and then double the value of the integral. Now recall that an even function is a function that is symmetrical in the y-axis. So the y-axis is a type of mirror. So you only have to integrate half of it and then double that result. And that's why we have the 2 here, and we integrate from 0 to the upper limit of 1 in this case. Now looking at the integrand, we have 1 over the square root of 4 minus x squared. Now the primitive will involve the arcsin or the inverse sine function. So that's our first clue as to what the primitive function is going to look like after we integrate 1 over the square root of 4 minus x squared. Now the way I'm going to work this out is I'm going to factorize 4 from the 4 and the x squared inside the surd. You'll see where this is going shortly. So factorizing out 4 from here and here, we get 1 over the square root of 4 outside of 1 minus x over 2 in brackets squared dx. Now x over 2 in brackets squared, when we expand that, is x squared over 4. And that's what happens when we factorize 4 from the x squared here. Now taking the 4 outside of the surd, the integrand becomes 1 over 2 times the square root of 1 minus x over 2 in brackets squared. And the 2 in the denominator can be written as part of the numerator as a fraction inside a larger fraction. So the integrand becomes 1 over 2 over the square root of 1 minus x over 2 in brackets squared. At this point, the integrand is in the form f dash of x over the square root of 1 minus f of x squared. As a side note, the first derivative with respect to x of inverse sine of f of x, using the chain rule, is f dash of x over the square root of 1 minus f of x squared. So if the integrand is in this form, then the primitive function will be inverse sine of f of x. So our f of x is x over 2, and f dash of x is the derivative of x over 2, which is 1 over 2. So performing the integration and taking note of the 2 here, which we need to retain, we get 2 times inverse sine of x over 2 from x equals 0 to x equals 1. Applying the limits of integration, we get 2 outside of inverse sine of 1 over 2 minus inverse sine of 0. Now inverse sine of 0 is 0. So that equals 2 times inverse sine of 1 over 2, which equals 2 times pi over 6, which equals pi over 3.